Very good morning, students. For this lecturing video session, I am going to teach you the next one, which is polar moment of inertia, radius of gyration, and the principal moment of inertia and principal axis. Okay. First, let me just start with polar moment of inertia. Okay. Fine. So the definition for the polar moment of inertia is the area moment of inertia about an axis which is perpendicular to the plane of an area is called polar moment of inertia. It is denoted by IP. Its unit is mm power 4 or mm power 4 or cm power 4 or m power 4, right? So in general, the polar moment of inertia is equal to the sum of the area moment of inertia about any two mutually perpendicular axes in this plane and intersecting on the polar axis. So which can be mentioned mathematically. IP is equal to Ixx plus Iyy. Okay. So that is, if Ixx and Iyy on the area moment of inertia of an area about the central intraidal xx and yy axis respectively, the mathematically the plane moment, the polar moment of inertia can be written as IP is equal to Ixx plus Iyy. Okay. So next one is radius of gyration. So radius of gyration is defined about an axis for an area radius of gyration about an axis for an area. The elemental parts of an area are concentrated at a radius from an axis such that the area moment of inertia about the same axis. So let me just consider a lamina of any cross section, and its horizontal axis xs. This is the centroidal axis, right? Centroidal axis, and this area A. So this what I am going to do is this I am going to convert that in a concentrated form in a strip form, right? In a strip form I am just going to consider this. So assume this is xx axis, that is centralized xx, right? So this is a strip form of same area. This is whatever area is mentioned in this cross section, I am going to consider in the strip form, and this is the area, right? And its distance from the axis, that is the radius, that is the radius k. So the radius of gyration is denoted as k. So since along the x-axis, so it can be denoted as kxx. So if it is of with respect to y axis, then this can be denoted as y axis, and the area which is in the strip format, there is a concentrated area of the same area, isn't it, from the axis y, that is central axis. This can be denoted as radius in y, right? So which can be denoted as about the centroidal axis xx. Then this can be written as Ixx equal to, that is moment of area moment of inertia is equal to kxx square a. So this can be denoted as kxx equal to root of Ixx by a. Now the central axis is about y axis. Now about the y axis, then this can be written as Iyy equal to kyy square a. So kyy equal to root of Iyy by a. So the SI unit of the radius of gyration k is mm or centimeter, because it is radius, right? So that is distance. So distance is always measured in mm or cm or in meter. Okay, so this is so what I did was how did I explain? So this particular cross sections area is been formed into a strip form of this concentrated area. So with respect to x axis, this much radius from the particular strip, so that is kxx, and for with respect to y, it is kyy distance, and it is with respect to the area moment of inertia about the same axis, then this formula has been arrived. So the SI unit of the radius of gyration is mm or centimeter or in meter. Fine. Next, the principal axis or principal moment of inertia. Principal moment of inertia and principal axis. Okay, so what it says, the moment of inertia about the definition of principal moment of inertia is the moment of inertia, this area moment of inertia of an area about the principal axis is called as principal moment of inertia. So the axis at which the product of inertia is 0 are called principal axis. So if the axis is passing through the centroid of the cross section, it is known as centroidal principal axis, and the corresponding moment of inertia is known as the centroidal principal moment of inertia, isn't it? So there will be always be two principal axes as given point the area, they will be mutually perpendicular in each other, that is the x and y axis, isn't it? The moment of inertia about one of the axis will be maximum and the other will be minimum, isn't it? So for an example, if I take cross section of rectangle, it is x axis and it is y axis. If I take the moment inertia for x axis, that is ix is equal to, you will get some value, and if you take the moment of inertia about the y axis, that is iyy, you will get some value. So whichever has the more resistance of the inertia, there is a resistance of the bending or the resistance to the twisting or rotation, right? So that is solved by the principal moment of inertia. That's what is the moment of inertia about one of the axis will be always maximum, the other will be minimum. So where you have the maximum resistance, so accordingly you have to place it. Suppose for an example, weight is being placed in such a way. Okay, as weight. So with two support, it is being placed on a slab. For an example, assume this is how it is placed. So this slab should withstand the weight of the ball. Suppose the slab of this cross section, assume of this cross section is being kept. Right. So, and one more cross section I have. So the similar way is the position is different now. So this position has been different now. How similar slab, this has been placed in different way. So if you just keep in this manner, its resistance, that is inertia, will be minimum. So this will bend and there is a chance of breakage of this slab. So suppose I keep this position as in this format, this is a vertical instead of the horizontal. If I just keep the vertical position, this construction, this slab position will withstand the load of this. So in this position, the moment of inertia will be minimum. If I keep the object in this position, the moment of inertia will be maximum. So the maximum moment of inertia is called the major principal moment of inertia, and the minimum moment of inertia is called minimum principal moment of inertia. So there is a formula for it, so which can be denoted as I max equal to Ixx plus principal moment of inertia. There is a formula Iyy divided by 2 plus root of Ixx minus Iyy divided by 2 the whole square plus Ixy square. Then what about I minimum, which can be written as Ixx plus Iyy divided by 2 minus root of Ixx minus Iyy divided by 2 the whole square plus Ixy square. Okay, right. So the I max is nothing but the major principal moment of inertia. I minimum is the minimum principal moment of inertia. Ixx is the moment of inertia about the horizontal centered axis, that is x axis, and Iyy is nothing but the moment of area about the vertical centered axis, that is yy, and Ixy is nothing but the product of inertia of the area about x and y axis. Right. Now the position of principal axis. Formula can be written as tan 2 theta equal to 2 into, that is minus 2 into Ixy divided by Ixx minus Iyy. Suppose if you take the moment of inertia in this way, it is Ixx, Iy, you will get minimum and maximum. Suppose at what point it will be maximum? In order to find this, the position of principal axis being used. Suppose assume this xx is being tilted in this way. This is 90 degree, right? So now I'm going to consider this as x and it's 90 degree. It's 90 degree. This is y dash and at an angle of theta. Right. Now you know that theta, if it is of this 90 degree, you will get some moment of inertia. Whether that moment of inertia and inclined position inertia will be same? No, it won't be same. It will be different. So with that, you have to find which will be the maximum value at what angle the inclination, the moment of inertia will be maximum. That is to be calculated based on this formula. So you will get two values. The first one is theta, some value you will get it, and next one is theta plus 90 degree will get one value. So at what angle this the moment of inertia is maximum, you'll have to find that. Got it? So in order to find the principal moment for the unsymmetrical area, first the split into convenient parts, that is subdivided into equal parts based on the formula which I taught you for the moment of inertia, right? Then the center of gravity of this need to be find out, that is the x bar, y bar, that is the centroid needs to be found. Then after that, the area moment of inertia about the centroidal axis for xx and yy, that is Ixx and Iyy needs to be found out. Then product of moment of inertia of the given section about the centroidal axis, that is Ixy, to be found. After arriving all those things, to substitute those values on this formula to find it, and then substitute this value to find the angle. So in order to, after calculating all this thing, you have to check the result. Ultimately you have to check the result whether the calculated values are correct or not. Check the result by using the following equation, which is nothing but Ixx, that is the moment of inertia along the x axis plus moment of inertia about y axis equal to I max plus I minimum. If both the values are equal, the LHS and RHS is equal, then the problem which you solved is correct. Otherwise you have encountered some mistakes in between. Hope you have all understood the concept of polar moment of inertia, radius of gyration, and principal moment of inertia and principal axis. Thank you.